So I'm going to present the last four challenges that we've got described, and I'll just jump into it. So there are these four that we are going to see one by one here. So the first one is introduction of AI on training of industrial robotics. So the big concept and very current concept of artificial intelligence is present here. So it's transforming everything. Also, industrial robotics, the way it is taught and the way it is practiced in optimization. So traditionally, programming of robots was static programming. You made a program and executed it, and it happened what you had written there. But with AI, behavior is adaptive, it's data-driven, and so leading to decision-making on the fly, and there's contextual learning, so there's constant, everything is much more fluent and transient. So we expect here to have educational content with simulation of adaptive AI behavior in robotic tasks to allow the learners to experiment with data-driven decision-making, to visualize how robots learn from feedback or from the environment, to show that how the learning process progresses. So visualize it and make it like understandable. So these are all ideas to provide intuitive tools to explore AI-based automation. Well, the tools, intuitive tools that you can come up with as well, or exist out there, you've seen and are worth conveying to somebody who wants to understand this topic in depth. So the outcomes that we expect are a good understanding of the basics of AI in applied to robotics, like pattern recognition or learning loops, to recognize differences between rule-based and AI-driven control. So I think being able to distinguish those is a sort of basic building block of the whole discipline. To test and refine robots' behavior based on simulated outcomes, and to build awareness of AI's role in Industry 4.0 systems. So 4.0, 5.4, or in industry in general, what type of role AI is gaining in production, to the student to get a good grasp of or an understanding of this. Next topic, XR for remote and inclusive robotics education. So here the new concept we want to explore is it's remote and it's inclusive. So how have these things come together? So the idea is that there should not be barriers for learning about robotics, and XR allows for those barriers to fade, and the content is to show how XR and its features, its strengths can allow for those barriers to not be there. And barriers, we're thinking in terms of distance or not being able to get to a robotics lab, or a robotics lab that does not have much equipment. So that's a barrier for learning robotics. XR can circumvent that. And very importantly also, the accessibility barrier. So persons that for their profile, they may have some limitations or disabilities, which may be physical or sensorial as well, and definitely also cognitive. So there may be some limitations for people to access information in a conventional way, traditional way, but XR may cleverly be used to get around this aspect. So that is what is proposed to be explored here. So with objectives like developing XR modules that are accessible across devices and locations. So you don't, almost with any device, even with a computer or any kind of glass, I can I can run some lecture or some content from anywhere. To be able to go around a virtual lab to get access to inclusive features like voice, language, traditional interfaces. So no need to use the ECS channel, and we'll talk about that in the next challenge as well. And so the outcome would be to understand these core concepts and to understand how navigation around a lab for practical skill building can be set up in a more effective way, and to adapt diverse learning needs and abilities, or adapt to those to the diversity of needs and abilities of learners and contexts. So it's a very challenging challenge, this one, but I think it can be very rich, and it can get a lot of the strength, or untapped strength of XR that is hidden out there. We're going to talk about multimodal interaction for XR-based robotic training, which is, I see it in my mind a little bit connected with the previous one, but it's a topic on its own. So communication with a robot can happen through many channels, and multimodality looks into providing multiple channels of communication, both input, the person towards the system, or output, the system presenting information for the person. So if you're running some glasses, head-mounted displays, you see the information, but audio is there also to be heard, and there can be other actuators like haptic ones or so on, and you can bring in the information with the controllers, but you can activate gaze tracking, for example, or even like other type of gesture recognition, or the multimodality allows for communication to be natural. So which natural means it doesn't need to be learned. It's the way humans communicate normally, and allow for a good immersive experience that is also accessible. So persons with challenges can find a way around that. So we expect to develop XR modules using multiple input modes to simulate robot operations controlled through natural interactions, and to allow to the user to switch easily, seamlessly between control methods, change from one way of communicating with the robot to another, and with all of this to promote inclusivity, and definitely for absolutely everyone, a good user experience. So that's going to be a good, as an outcome, a good understanding of all of this, to learn to a good knowledge and sort of grasp of how to operate virtual robots with natural interactions, and to evaluate the effectiveness of different control strategies to realize what is working and what is not yet working so well. And the final one, to close my talk on the edge of I think I'm 1 minute overshoot already. I'll just say gamification. Everybody's got an idea about what this means, but we're talking about game dynamics built into the XR scene to be able to learn content in a more motivated way, with scenes that are active and engaging, and that extra motivation can enhance, retention of knowledge and help with acquisition of new skills. So we expect to have these things, all of these things implemented in the scene, or well, I mean, like to show them or to talk about them, to make contents that are goal-oriented with scores and progression of to show the progression of how new material is being covered, and with all of that to hold and keep up the motivation of the users, and also considering solo like one learning through a lonely process of going through the content or also collaboratively. And from the rest of the bullets, I think the most important one is the final one, which is to have gamified metrics to be able to track and analyze the performance and to get a good gamified experience from all of this. And I think that's all the information.